Hey, welcome back to Azure FunBytes. My name is Jay Gordon. Today we're going to talk containers. Let's get into it.
You may have worked with virtual machines to deliver your application, but do you really need to manage all that underlying OS and dependencies? By using containers, you can create environments for your applications that are isolated from the actual computer or node that's running them. There's no hypervisor like Hyper-V or VMware. Containers can be run anywhere, on your local computer, in a data center, or even in the cloud, like Azure. Docker is a tool for building images for your containers, allowing you to package and share them in registries. Registries act like repositories, just like we keep our code in. Registries act similarly to our code repositories, giving us a place to track our changes and then eventually deploy from.
I'm Erik St. one of Microsoft's cloud advocates. When you get past the hype, containers are just highly configured applications that allow you to control how much of a given system resource that the application can consume, as well as what system resources that the application has access to. The real power of adopting containers is how they lend themselves to reproducible builds, simplified packaging and distribution, and the resiliency guarantees that we get from using things like container orchestration.
Utilize services for on-demand containers like Azure Container Instances. Deploy complex distributed applications via Azure Kubernetes Service, or even build web and API-based applications with web app services and get fully hosted web apps with SSL auto-scaling and all the other features integrating your container with the rest of Azure.
You can see even more documentation in the link below. Go ahead, click that now, get up to $200 in free Azure credit. Once again, I'm Jay Gordon, and I'll see you next time on Azure FunBytes. Hey everybody, it's Jay. Welcome back to Azure FunBytes. I am so glad that you're all here. As always, it's another great opportunity to spend some time with you, talk about Azure, meet someone that has spent some time working with Azure and doing some really cool stuff. And not just that, but also someone that doing a lot of other really amazing stuff. So we'll bring our guest this week, Erik, in just a moment. I'm going to pull that back a little. So this week, we're going to talk about containers. I think this is a really important part of what we've been doing in Azure FunBytes. We've been going through fundamentals of what really makes up Azure and how you as the user can start using it. So to bring in, I'd like to introduce Erik St. who's with me now. Hey, Erik, how are you?
Hey, Jay.
It's great to have you part of this. I am really, really appreciative that you got some time to spend with me. We're all kind of crazy with things to do. And I know that time is of the essence. So thank you so much, Erik.
Oh, not a problem. I always enjoy doing this stuff. So
awesome. So today we're going to talk a little bit about containers in Azure. And it's something I know you've got a ton of experience with. But you've got experience with a lot of other interesting things that I want people to know about. So we're going to talk a little about you before we even talk about technology, specific that part of today's episode. So Erik, you've been part of the Go community, I think, which is really, really tremendous for a while. Can you talk to me about like how you got started with the Go community and how that's kind of been part of what you do with containers?
Yeah, so I got into Go in around 2011, still early days, pre-Go tool, pre-1.0 release. Got really, really into it. Started organizing a conference, GopherCon, with a colleague of ours, Brian Kettleson.
Oh, yeah, Brian. Brian was on very recently.
Yeah, co-authored Go in Action together and some stuff like that. So been in the Go world a while. And at the time, everybody was writing everything from scratch in Go. You couldn't find libraries for anything. So often would search GitHub for recent projects that were released in Go. The world was so small back then, you could look at every new project that came out in Go. And that's how I got started in containers. Docker hit the scene and I was looking at it. And at the time, I was building my own distributed systems thing in Go and trying to deploy applications. The Go ones were easy. They were static binaries, but we also had Ruby that we were trying to orchestrate. And containers were just like the perfect solution for it. And threw away what we were working on, did that. And then eventually Kubernetes came out, and that was a way better way of orchestrating stuff than what we were working on. Parts of it did live on.
Am I right that a lot of Kubernetes can be extended using Go?
So all of Kubernetes is written in Go. Most of the tooling in that ecosystem, both for Docker is also written in Go. So Docker and Kubernetes both written in Go. Most of all of the tooling and other things, Istio and all of these things you see are also written in Go. But yeah, the interesting thing about that distributed systems framework we were working on, part of it did live on, which was SkyDNS, and that is what did the DNS-based service discovery for Kubernetes for up until recently.
So, very cool.
Didn't have to throw away all of it.
Yeah. So you're out of the Florida area, am I right?
Yeah, Tampa.
So how's life for you right now? I know things are a little hectic. Are you doing all right? How's your family? How's everything going?
Yeah, things are going good. We're mostly hanging out at home, and that's giving me more time to code and things like that. So there's not a lot of errands.
Anything interesting you've been working on lately?
So on my own Twitch channel, I've been working on a Twitch bot because it's like a rite of passage for people on Twitch. So I'm allowing people to add effects to my voice using like VST plugins. All of these LED lights, people can like flash them and change the colors, and it's been kind of fun.
Awesome. So
aside from that, Crustlet, which I think you mentioned.
Well, let's talk a little bit about like what we're going to get into today. And so I think it's really important to tell people that one of the big things that we've all kind of worked on at Microsoft has been advancing this idea of containerization around your applications. And I think that it's been a huge boom for our customers, and containerization in general has been huge for everybody. But the one thing that I've noticed at Microsoft is that we've really taken a container-first approach on almost all new technologies. And I really find it to be something that people are just leveraging to be better at what they do, because things are faster, easier, and they make a little bit more sense with containers, is the way I feel. And I know you said, when you strip it all down, it's just a process on a server.
Right. And even outside of that, we talk about what containers are and how we get into orchestration and things like that. The very first problem it solves is packaging and distribution. Right. When you think about all of the dependencies that go with deploying an application, it's hard to reproduce, and even build environments, we end up with like these very, very specific build machines, and then you change the dependencies on the machine to build another application, and then you can't roll back because now you're rolling back the dependencies, and containers sort of wipe all of that slate clean. There's an analogy where we talk about pets versus cattle in distributed systems, right? When you get to a very large scale, you can't have some unique machine. It's too hard to keep track of and to update. It's easy to just have machines that you can just throw away and get a new one.
So let's talk about that. Let's get started with that kind of idea. So yeah. Erik, I want to talk first about, and we've got 3 problems today, and here they are in my little thing. So my app is on a VM. Can we move it to, or can we move it to a container? I meant to say, can we move it to a container? And I think that it really all depends. I think that's the way that I've looked at it. And a lot of people have told me, you really need to think, can you put this particular application in a container? And I want to know if you kind of agree. And the thing that I've always heard is it depends.
Yeah, and there's always an it depends in tech, right? Always. I think that adopting containers isn't as problematic as when we get into container orchestration. I think that's the thing that people are really quick to adopt. If you want the reproducible build aspect, we'll talk about how to do, builds out inside the container registry and things like that as well. You can get all of those benefits and treat the container like an app. And then you just need a VM and Docker, and then you script the starting of that the way you would anything. People are very quick to adopt container orchestration, which comes with its own concerns. You really have to understand how those systems work, how they behave, how they fail, so that you can troubleshoot them. And I think people are very quick to think, well, Kubernetes solves all of the problems for me. And, I used to demonstrate in workshops to have somebody take a replica set, which guarantees a certain number of things our instances of this app are running, and tell them to pick a very big number, like tell it 10,000. And the Kubernetes scheduler, and this was the trick, right? The pod definition didn't say how much CPU or memory it needed. And the scheduler was like, oh, there's probably room. And what happened? It saturated a node. The node couldn't communicate with the cluster. The cluster thinks the node's down, tries to reschedule all of the work, and we take out the whole cluster with it, right? There's a lot of power there, but you also need to understand what you're using, and people are really quick to adopt it and go straight to prod.
So let's talk about going to prod a little bit. All right. So you brought up a great thing to start looking at. So this is an application that we have in prod right now, and it's on a virtual machine. And it's right now just a clock. That's it. That's all we're working with. It's my favorite stateless application. And so I think what we're going to do when you start looking about containerization, and the first problem that you really need to answer is this application container ready? Okay, can we put this in an image and will it start? And I think it really all starts with, let's look at the code a little bit, Eric. So this is the basic code. I'm going to share it in our chat for everybody. And really, it's just React. It's just JavaScript. It's stateless. There's no backing by database. There's nothing at all. And what I've done is added some things that'll make it easy to do. But when we want to deploy it, and you see I've got some deployment models that we've already got ready for us. But I just wanted to think, like, when you're talking about what can be containerized, what's the first thought for you on the types of applications?
Well, I mean, you can containerize pretty much anything. Like, you watch Jess Frizzell, right? She'll containerize everything. She containerizes her desktop apps. So really, if it's an application, you can containerize it. The question really becomes, is there a better thing for it? If it's a static web app, then do you need the container, or is some sort of static web app service or CDN or something like that really what would serve the purpose better? But yeah,
I think some of our static servers that we have, I think they actually build a container in the back end anyhow. So I think that's the one thing that I've noticed a lot about Azure is a lot of these services that we have, they actually automate the process of taking your code and containerizing it. And I think that in itself has been a really interesting part of working with Azure lately.
Yeah, and the other side of it too is differentiating build time dependencies versus runtime dependencies. So even if you don't run the application in a container, you don't create a container image for your assets, your artifacts that come from the build, having a container for the build where people can reproduce the build, a CI/CD system can reproduce the build, that's also very powerful.
So you brought up something really good that we're going to do next. So I've got my shell up here, and we're going to actually begin the process of containerizing this. We're going to build an image for this because we've made a decision. Can we containerize this app? And you said we could just containerize just about anything. And so it really starts with the Docker file. And so you have spent a lot of time explaining to people like what the Docker file is. I'm going to bring up one right now. Okay. And it's extremely, extremely simple. And let's talk about each line and what's going to kind of happen when we actually run this. So at the front, we've got from node 12. And if I'm right, that's just going to take the base OS, and then it's going to provide just the runtime for Node.js, right?
Yeah, so here's the interesting thing. If we think about how containers are constructed, and I'm gonna talk about Linux containers because Windows containers are Hyper-V VMs, so they don't technically operate this way. But when we're talking about a Linux container, it's basically an image. The image is a zip file with a manifest file in it that gives the container runtime information about what thing am I executing when I start it up. Are there environment variables I need to pass to it? What do I set its CPU and memory to? All of these types of things are just in a manifest file. And then it's just a series of zip files. So when the runtime pulls the container down, it's just extracting this zip file somewhere. And if you're familiar with chrooting, it's basically doing that, right? So you get this illusion of this is my world, but really you're just in a directory. So that from is the starting point. That is what that directory structure looks like at the very beginning, which is often, say Ubuntu, the same thing you would look at if you looked at /, right?
Exactly. So the big thing that you're going to need to do what we're going to do first is you're going to need to have Docker installed. It runs just about on anything. It seems like any major computing platform, you go to docker.com, you can get it. So after we kind of say what our user land is going to be, essentially, we start saying this is where our application is going to live in this particular directory.
Well, really what this is saying is telling Docker every command that I run from now on
in this directory
is
right?
in this directory. So it's effectively changing directory as far as, all of the commands execute as if I'm now in this directory.
And so now what it's going to do is it's actually to copy the package JSON file to build then using the Node 12 runtime that we built, our application is going to install it. It's going to copy it eventually, the bundle that's been produced. And then we're going to expose it to the world and basically say, start. So what we're doing is something similar here, but we're using the full operating system. We're using a hypervisor. And we're also working with all the things underneath it, including all the concerns about networking, scaling, disks, operating systems. Seems like a lot of crap to me that I feel like if I'm just producing a simple stateless application, I should not have to do.
Yeah, and especially when we get into container orchestration, you'll see that your resource utilization will get significantly better, right? When you're running all of these VMs for things, you're using all of the memory and CPU, you're allocating it for that. So you can't pack things as tightly as you can with a container.
So I'm going to show everybody, there's two ways that we can kind of take this and run that Docker file that we're going to show everybody today. So the one way, I'm going to open up this repo in two different places. So this is a Cloud Shell. We're going to use it here to show everybody that we don't need to do it locally. But if we want to do this locally, what we can do is Docker build -t. Am I right? Is that the name?
Yep. So that's the tag. That's what you're going to refer to this image as.
Okay, so I'm going to call this React clock basic. And then what I'm going to do is give it a tag of v1. I'm going to say this is version 1 of this. And then what I'll do is boop.
Now that dot, what that dot is that's the context. So that it's going to copy all of that information kind of into the Docker scope. So now when you're saying I want to copy a file, it's relative to that context that you've given Docker.
So there's another way we can do this too. What we can do is build something known as an ACR, an Azure Container Registry. And that container registry will allow us to actually use some tools that are built into the CLI with Azure. And you could do this in the CLI on your local computer, but I want to show you that it's easy to do in the Cloud Shell. So I've built this container registry right here already for us. A lot of the resources that we're working with today, I'm going to pre-built because they take a little bit to actually work with. So what we could do or could have done with our Docker build right here is I could have logged in to this server, this Docker hub server, if you will. That it's like the dockerhub, which is a public place to keep all of your images, but we want our images private. We don't want the world to have access to our images. So we use what's known as a container registry, and it's private. It's got all these different things like access keys, encryption, replication. And if I'm right, Erik, this is kind of like the basis for most deployments if things start here.
Right. We talk about kind of packaging and distribution. So the creation of the container is the packaging, but really the container registry is how we get distribution. So now we move to this model of a pull versus push. So you declare state of your system. I need this container to be running, and then it goes out and gets it and fetches it. So we create kind of this declarative API for what our system should look like.
So I'm going to give everybody this documentation. Let me shorten the link for you. This is a really quick start for you to actually build this yourself. I just wanted to grab the docs so I can just show you how simple the command is. So we've already got this. We've already created a container registry. We've got all of our stuff for our Docker file. We've already gone through that. And now we can see that Azure CLI has a command built into it to actually build the container. And so I'm going to start typing out what's going on. And if you don't mind, Erik, I'd like you to kind of tell everybody what I'm doing.
Sure. So ACR, which is the container registry itself, which allows you to kind of authenticate and push and store images and roll back. It's going to also allow you additional ones. So what Jay's doing right now is ACR actually has something known as tasks, and that allows ACR you can trigger a task in ACR, or you can ask ACR to be triggered on things like I push to GitHub, and then ACR will automatically build the container that's part of that registry. And it can even go as far as that from line that Jay had that says what the base image is. If the base image also lives in ACR, like you have some base image that's shared across all of them, then ACR can be triggered off the fact that a base image has been changed. So you can kind of get like this chain where you push to GitHub a change to the base image, ACR rebuilds the base image, ACR recognizes that the base image has been updated, and then rebuilds all of the dependent images for you.
So right now, AZACR can build this image for us within the registry. And the other way, like I said, we can do it is so I can go back to the ACR. And I can go here to the access keys. And if I wanted to log in from my local computer, very, very simple. Let's just bring up here the terminal within VS Code that we were working with. And all I have to do is click enable for an admin user. And then what it's going to, enable. So it's disabled by default. And I want to show you that. So what we can do is just this. Docker login. And we'll provide the container registry. And so it's just going to ask me a username, and my username is right there. And then Azure is going to provide you with credentials that you don't have to manage. They're fully managed, and they're rotatable very easily. You can just click a thing and it'll rotate the credentials. And so you don't have to do it with this username and password. There's access identity versions that you can use to have certificates, local trusts. There's also creating individual trusts between ACRs using surface principles and the things that they're eventually going to deploy to. So Eric, you want to tell people just a little bit about that as we get into the Kubernetes part? And I think we're going to get there real soon.
Tell people about what?
ACR and that service principle that you create between like ACR and Kubernetes or something like that, that you create a trust.
Yeah, so if you're already using things like Active Directory and things like that, you can use that to manage who has access to your container registry and images and things like that. I think what Jay's referring to is once we get into some of the container orchestration side of things, we have to sort of talk about how do we permit our nodes in our cluster access to pull these images and things like that. And in the container space, or in the Kubernetes world, that's actually the image pull secrets. But Azure does have ways of doing managed identity as well. So we kind of get like, well, this service, Azure knows that this is a particular service, so it gets a service principal, and then you can kind of authenticate, app service to get access to these things.
So I want to show everybody
like a whole show on service principle stuff.
Totally. So I want to show everybody that right now there's two of these things going on at the same time, because I just want to show them the big thing about using Docker containers is also their portability. The fact that you should be able to build them most places if there's a computing environment with the Docker engine built in, or the fact that you should be able to run the Docker container image that you created almost anywhere.
Yeah, and one thing I want to point out here is you see all of these like waiting and layer exists and all of these individual pushes. These are individual layers, and the layers are the individual kind of commands that you saw in your Docker file. Mm-hmm. And that's an important thing to note here, because if a layer already exists, it doesn't need to be pulled or pushed again. So when you're constructing your Docker file, you really want to think about which points of this Docker file change more frequently than others, and leave those towards later steps so that you don't have to be pulling and pushing as much data, because you're not recreating layers that don't need to be recreated.
So let's show everybody as we create these things, these images, and they go into repositories, and it acts like code. I mean, that's the big thing that I want everyone to think is that these ACRs also kind of look at what you're building as like another process of software development, keeping everything and version controlling it and doing it so that you can remove some of those layers if you need to, or you can actually clone an individual layer. Am I right?
Wait, you want to pull an individual layer?
Aren't there ways to like pull versions based on like individual layers and remove something that you did in the past to kind of recreate if you want to like rewind what an image looks like?
I mean, you can rewind to prior versions. I mean, you could look at the individual layers if you wanted to. So you could probably take the tags that existed for those and pull.
So I think the important thing we all should tell people is these manifests right here. If you look inside of it, this is just like what makes up the things that are in a saved image container. Each individual manifest and all the different layers are part of it. I think the thing that's really kind of interesting here is that we're just keeping this all so that we can do something with it else in the future. Like this is just a storage point. This is not an active like hosting portion of it. This is just storing our containers before they do something else.
Correct. You're just taking the image and pushing it up there, and then something else is downloading it and executing it later. Now, the thing with running ACR is if you're already in Azure, you're going to have it in the network, which means you're not going to have as much latency. They will also replicate it to other regions. So you push it to ACR once, but you have East US and a West US cluster. They're right there already. It's already been replicated.
So what I think we're going to do is we're going to take that container image. We can see here it's built, and we saw it actually in the portal. We were able to go click, see that the image was there. We saw the manifest, everything. So let's actually load it onto something. So I think the bare minimum is an Azure container instance, if I'm right, and that's just a pay-as-you-go container that you can basically load any image in. Am I right?
You're talking about Azure container instances?
Mm-hmm.
Yeah, so those can be container groups. So you can kind of, if you're familiar with Docker, it's kind of Docker Composey, where you can deploy this group of containers. You pay per second that they're running. They are great for kind of burst workloads. They're fantastic for like batch jobs and things like that. Like I just need to spin up a bunch of resources and retrain a model at night. Well, I don't want to have a bunch of infrastructure that sits unused all day for this. So ACI is a really, really great way of doing kind of these on-demand things, pay per second, tear it down.
So if we want to do something like ACI, we can do that, and we can build containers. I showed that in the video in the intro. That you can build them just with the command line, or you can use any of the other different things that Azure has to go through ARM. But the thing I want to show everybody is that if we need to, we can also run the container that we built right into a web application. And it doesn't even have to be a front end. It could be an API. This can host it for you and then give you all the other hosting things that you kind of like to think about. So we're talking about SSL, we're talking about scaling, all these things. And so we can actually, when we build this, we can click Docker container. And then we can select our operating system as Linux. We can pick where we want to actually keep it. That's where our ACR is. We're just going to use East US. And then we can pick the kind of hosting plan that we want to have. We'll just click Create New, and we'll call it, not load balancer, FunByte. But a load balancer is created for you, which is awesome about this service. And so now what it's going to do is right here, it asks us to go to Docker. And it's going to ask for that image. So we can see we've got some options. And just like you said, Erik, like here's the Docker Compose, that we could provide a Docker Compose file here if we don't have an image already ready to go. But we have an image ready to go. So what we can do is go to this quick start. Instead of quick start and one of the pre-built images, we're going to use one of these three. And so dockerhub, am I right? That was just like their public service that eventually kind of made a paid private version.
It's like GitHub for people to store container images. Now, be careful, because you will often look on dockerhub to find, something that you want. You're like, I want to run an asterisk server, but I don't want to containerize it myself. So you go search dockerhub for it. Lots of bad actors love to publish images to dockerhub for that
Oh.
reason, because people will just, hey, asterisk. And I'm just picking on that on another one of these streams. I picked on, I think, Elasticsearch. I'm just, I don't want to call them out, but yeah. So be very careful. When you go to dockerhub, you can actually see the Docker file. You can see what's being executed. Like, you wouldn't hopefully include just a random library off GitHub into your project without kind of auditing it first. But
so let's go to that for a second, because that's a great kind of way where we can bring up this thing. This is one of the big reasons why you want to use something where you pay more attention. You know what you're providing. Using a public image can be kind of scary. I don't know why that did that. But anyway, back in 2018, it was found out that a bad actor, that these companies, Fortnite and or Fortinet and Chromet Tech, found out that bad actors had actually been putting in a lot of, if I'm right, it was a lot of JavaScript containers. There was a library that basically just Bitcoin mining, and people didn't realize it. And say, if I'm right, like they would see CPU utilization up a little higher, but they just couldn't figure out why.
Yeah. So yeah, it's something to be extremely careful about. And then if you end up running that container as the root user, you're done. So
Yeah, absolutely.
You're still finishing here. After you finish deploying through the web app through ACI, I want to kind of point out another way that you could deploy here.
Cool. So I'm going to go ahead and go to monitoring. And what we can do is you can enable application insights. But if you're using containerized app, not using the code version, it can inject some of those things for agents that it needs for application insights. So this is one limitation of it here. And then, of course, tagging, if we want to, we can just go environment, and we'll call it production. And then we'll click review and create. And what it's going to do is it's going to, as we talked about in the past with Azure Resource Manager, it's going to validate that everything that we're doing here is okay with Azure Resource Manager. And then we create, and then we submit the deployment. And so this is going to take the container image we built. It's going to throw a fully hosted version of the web services. So we'll get the underneath the underlying infrastructure. We'll have all the orchestration. We'll have all these things done for us. But then it gets a little bit more complicated, and I'll let you talk about that, Erik.
Not necessarily complicated.
Different.
So there's two other ways that we can do this. So one, if you're a command line person, there's the AZ tool, which is how I usually do these things. And I mean, I can whip up what that command would look like to deploy it through the command line.
Sure. You want to just talk me through what you would want me to do?
So really, it would just be an AZ container create. Then you would give it a -G for the resource group. Then
so we'll do FunByte. Yep.
And then a -- name, and then you would name whatever this is going to be, and then a
my browser locked up for a second.
Then -- image to tell it what the image would be. And then you'd have a -- ports to tell it what ports you're going to expose, and then a DNS label. And I mean, we don't have to go through all of this, but that's basically what it would look like. Now, in recent releases of Docker, we actually have changed this up a little bit. So you can do a Docker space context space create.
Okay, let me try that over here. It's because we've got Docker and I've got my image built. So Docker, okay.
Create or context create ACI, and then just you can name it FunBytes if you want. And that's going to be a special context. So when you execute commands in that context, that's what you're talking about. Go ahead and run that.
Oop, did I forget something? Exactly Docker. One argument. Dot?
No, it should be Docker context create ACI. What are you missing?
It says exactly
right?
one. It says one argument. Is it one of the options that I'm not saying right? Let's see. Do I need to specify the host? Because I don't see.
Maybe you don't have the right version.
It's possible. Hey, that's a thing I need to know. Then I probably need to update my version of Docker just because of having more up-to-date versions. Can I do it from here? I don't know if the Docker engine's running here.
And I could be wrong here.
Do you want to?
Oh wait, no, it does have. It is just one. Wait, no. Yeah. What am I missing here? So maybe I just did that.
Here, let's see. Yeah, if I'm right, this is pretty new documentation, I think. Docker log in Azure. Okay, so I need to do that first. Let's do that. Docker log in Azure.
Okay, so you're logged into something else. Okay, that's why I'm like, I swear it's Docker context create. I'm just missing the login.
So I should be able to just do this one if I'm right. So I'll just log into this. No, excuse me. I went to the wrong place. Access keys. So I should be able to just do this. It's going to ask me, wait, log in Azure. Does it want to know my ACR?
Yeah, so just do a login Azure. I think this should be, it should make you log into your account. Okay, I'm surprised it doesn't pop your browser.
Let's see. Log into, if no server specified, the default is defined. So where's the server? Okay. I don't know. I've never used this before.
So I'm surprised it's asking you for a username and password. And it could just be you're running an older version. But Docker login Azure pops the browser for me to authenticate with my Azure account, not with the specific thing.
Do you want to share it and show?
Yeah.
It's up to you if you want to. Go for it. Let me remove myself.
All right.
My
share screen.
Computer's locking up a little, so just give me 1 second. There we go. Okay, so I remove that. And then go ahead and share your screen and it should add it.
And we want to share that screen.
Okay.
And then
recursion.
Okay, there we go.
Can you just make it? Yeah, bump that up. Cool.
All right. So what we should get if we do a Docker login Azure is this going to pop this. It's going to
just like an AZ login.
Yep. All right. So now what I can do is a Docker context create ACI, and we'll call it FunBytes. Now it's going to ask me to select a subscription. We're going to do this one. I don't know. I guess we can throw it in the default resource group. Mm-hmm. And then from this point on, we have this special context. So I can just do what do I have for images? Docker images. Docker's not running.
It happens. I do that sometimes myself.
Is that a second to start?
Because I normally don't keep Docker running in the background because of the like if I'm doing something like video editing or whatever, and I'm not in a need to run containers, I'm certainly not going to leave the Docker engine running.
Yeah. What are you talking about, Docker?
All right, we can move on.
It might be because I had already executed. It's still starting.
Okay. So, gotcha. All right, there you go. Docker PS. There you go.
Right.
Okay, cool.
So I know that I have like a demo that I set up the other day. So this HTTP hello slim. Okay, so what we can do is we can say Docker. We can tell it the context now that this is where I want you to deploy. And what did we name it? FunBytes?
Mm-hmm.
FunBytes run just like a Docker run. We want to daemonize it. We're going to give it the name. FunBytes. I'm assuming that's not taken. We're going to map port 80 container. Let me hide that.
Mm-hmm.
Port 80 in the container to public port. And then I've already deployed it somewhere for the other thing. So we'll just do it this way. And this is the same Azure. Yeah.
And that's your ACR where it's all, and there's your image. Cool.
And
And so what that's doing is it's directly running it into an ACI, an Azure Container Instance. Am I right?
yeah.
Gotcha.
Oh, I took down that thing. If you pasted me your image, we could run it that way. But the idea here is
I
that
gotcha.
it's the same thing that you would do a Docker run for, except we're telling it this special context, and then it translates that to, hey, this is how you run that container
Gotcha.
in ACI instead, which allows you to just work with one command and not have to like translate your Docker compose or things like that into ACI container groups and things like that.
So we're going to talk about one more thing, is that when we get an application that gets really, really big, we've talked a little bit about Kubernetes before, but we need to start thinking about it in the context of our little clock needs to be up 24/7, 365. It needs to withstand failure. It needs to be distributed different ways across the globe. We may want to do different things with it. And Kubernetes is really taking the world as kind of like the big engine for applications.
Yeah, so there's a lot of things that are useful even outside of that. Like when we talk about Azure, you can run things in Azure Container Instances. We didn't really talk about it, but if it's like a web API, you could totally run it in web apps for containers. There's a lot of benefits there. Web apps for containers even allows you to scale out horizontally, and it keeps a load balancer in front of it. Kubernetes really comes into play when we talk about kind of east to west traffic, when we have a lot of things that are communicating with each other, and we want to kind of do auto scaling. It also is a way to not have vendor lock-in where everything speaks Kubernetes. So that's really where the power there is this sort of declarative API of how many of these things do I need running? Do I need one running on each node, or do I just need 5 running anywhere in the cluster? And how do we prioritize these things? How do they find each other, right? That becomes really, really difficult, is service discovery. And so, you know, it has the concepts of things like liveness probes. Like, is this application running at all? Do we need to restart it? A readiness probe that says, okay, I can tell that the application is running, but has it done all of its bootstrapping logic? Is it ready to be put behind a load balancer? There's a lot of power in kind of doing all of that stuff. And yeah, Kubernetes is changing the game up.
So let's talk a little bit about what makes up Kubernetes when you use it with Azure, because I think the big differentiator, because Kubernetes is Kubernetes. It is a singular like thing that you can use, and it doesn't matter who your host is or your cloud or whatever, or if you're running it in your data center. It speaks Kubernetes. But the point that we really want to show people is that the orchestration between, or for the underlying resources, differs between different cloud providers. And what we've got at Azure is a really simple way of building. I built this Kubernetes cluster. I created, I'll show you. I have a little script that I use that I love. I wrote it in Bash because that's what I know. I'm an old sysadmin. And I have this little script. You can find it on my GitHub. And what I do is ACR all in one. What I do, and I've got one already built together, is I kind of just give some variables. I create a role-based authentication service principal. And then what I do is I actually connect our service principal to our ACI, our Azure Container Registry. So I create our container registry, and then I create a Kubernetes cluster. And then I create this trust between our ACR and our Kubernetes cluster so that our images in there can go in there. And so then it creates our Kubernetes cluster. And then what eventually I do is I grab the credentials, which I think is one of the cool things is we don't need to hold credentials somewhere else other than going into a command line and just asking for those credentials. I love that. Where is it? Just it's like AZ, AKS
credentials, yeah.
Credentials. And then I think you need
to
get
-G, the resource group, and then
-bytes
name, the name of the cluster.
Yep. AKS 1 or 2. Yeah. Oh, get credentials. So what I do here is it'll actually get the information, credentials about our cluster so that we can start modifying it. And so what I'll do
control that you run locally requires this kube config that tells it how to communicate with the cluster, including credentials and SSH keys if you're doing mutual TLS. So what this is doing is going out and fetching those credentials and writing that kube config for you.
So everything that we're running is running on just a series of virtual machines that are our nodes. That's what Kubernetes is running on, is these 3 VMs that are providing you with redundancy across the nodes. And we can actually auto-scale them based on utilization if we want. Or we can manually modify them. But we can see the total amount of clusters, CPUs that we have and memory between our 3 nodes. And if I'm right, we can add additional node pools. And we can actually use different kinds of CPUs, GPUs, and things like that.
Right. So you would have individual node pools. So if you had some Linux nodes and some Windows nodes, or you had some GPU-based SKUs, but you don't want your whole cluster to be GPU nodes. And so you can do things like that. And then that gets into another concept with Kubernetes when we talk about like taints and tolerations and things like that. So that would allow you, say you have a GPU node, you can taint the GPU node so that no application will just get scheduled there. They have to just specifically grant a toleration for that. And then you can also use node selectors so taints and tolerations are how you reject things from just landing on the node. And then node selectors are how you kind of attract a workload to a specific node. And that can be something that's on the node, or you can attract it to a node that's running something. So if this app, you prefer it to run next to where the database is, you can attract those 2 workloads together. And you can either require this or you can prefer it, where it'll best effort try to schedule it there. And if it can't.
So what I did here for everyone is kind of just did a few of these. So kube control is the Kubernetes command line interface that we can use. And so what I can do is I can see the information about those 3 nodes just by looking at the versions here. I can get the services that's running right now. So this is the local IP on the kube network for our cluster. That's specific to the API that we can access, right?
Yeah, and so the services are really, we kind of have to, so the layers are, you have a container, which is an individual instance of an image that you've started up. Then you have a pod, and a pod is a collection of containers that move together, similar to how we talked about Docker Compose or the container group that ACI has. And then from there, you have these notions of like a replica set. And a replica set says, I need, some number of these running, and the cluster is kind of eventually consistent, and it tries to reconcile the difference. Oh, I only see 2, but you required 3. Let me start up another one. Somehow we had 4. Let me shut one down. And so that's how all of that stuff works. Services is how we put like a load balancer in front of that. So when you're when one service is trying to talk to the API service, it's talking to that service. Well, really, there's IP tables rules routing it, but we can think about it conceptually as you're talking to that service in Kubernetes, and it's deciding where you go, which one of the endpoints you're going to hit.
Cool. So I want to show everybody the real power that we got here once we've gone ahead and created a manifest. So a manifest is just YAML that tells Kubernetes what exactly we're going to do with the code that we've containerized into an image. So here's what I've done. I've provided a little bit of information. We're going to use the API for apps v1. We're going to use a deployment. So we're going to make a deployment of an application.
And now to kind of just add to that stack that I said. So a deployment basically has a replica set inside of it. And a deployment is just a way of wrapping this so that when we make changes, we can roll them out, like a gradual rollout, and we can roll back. And so that's what the deployment type does.
So what we've done here is after we tell the application what it's going to be made of as far as the pods are going to be eventually created to run the app containers. We're eventually going to grab this image from our ACR. We gave the image server information, and then we gave the name of the image and the version number that we've tagged it. And so all I really need to do here, and I've got some readiness stuff for health checks that I want and how much memory we should be using built in. But now to actually just make this work. So that's the cool thing. You also talked about the load balancer. So I set up a separate one for that service. And I just want to show everybody before we actually deploy this. So here's the service you were talking about, Erik. And what I do is I just named it a load balancer, made it really, really simple. I said that this is exactly what we're building. It's a load balancer. We said the name of the application that we're going to be using for it, which we established the first deployment file. But we could put this all together if we want, right?
Yeah, you could put all of these separated in a single file if you wanted. In addition to that, this is sort of like moving into a more advanced thing. A lot of people bundle their applications into something called a Helm template, a Helm chart. And Helm is kind of a way of packaging up all of these individual definition files, these YAML files, and templatizing them so that if you just need to change the version of your image, you're not having to go in and modify all of this stuff.
So what we're going to do is you see in kubectl, we have this, or kubectl, we all call it different things.
Kubectl, 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 yeah, kubectl, yeah, there's.
So we have this apply command that we're going to be using to actually load our manifest files. So we have our 3 manifests that are just in YAML, and we can just type kubectl apply, and then just give the
you
location.
need the -f to tell it it's a file, yeah.
Right, sorry. That's a file, and then we just say deployment.yaml. And so what it's going to do is Kubernetes has read the information that's inside, and then it says, okay, it's time for me to create pods. And so if we type kubectl, is it get? Yeah, it's get pods.
Well, yeah, you can kind of go. So this is actually multiple layers down. So if you do a kube control get deployments, you'll see your deployment there. And so, yeah, so you can see here 0 of 3 are ready. It's up to date. How many are available? But now you can look at kube control get rs for replica sets.
I want to just start also our load balancer.
Oh, yeah. Yeah, that'll take a few minutes because that's a special type of service that actually provisions a legit Azure load balancer. So now the deployment created a replica set, and the replica set determines how many of a given pod needs to exist. So this shows you the state that we're asking for 3. We've got 3. Now the replica set is actually what creates the pods. And I've got a bunch of slides that I've done talks on how kind of the control plane works. We could probably do a fun little episode where we talk for an hour on just how the control plane works and how this kind of reconciliation loop happens.
Is it? I thought it was -w. No, it's not. It's not sure. It's get. Dummy. And I think I can do a watch -w is 0 or something like that for watch.
I think it's just W.
Oh yeah, there it is. Yeah. And so now what we can do is just watch what's going on with our pods and seeing if they're online, and it shows that they're all ready. So it went through the process of, and if I'm right, we can just type kubectl logs. And then what we can do, can we specify a replica set for the logs?
You need the pod name.
Okay, so we can just do this one right here. So -p. And so it gives just some information. Nothing in the container yet, I guess. Is that what this means?
Error from server, previous terminated container.
Weird. Let's check on our services. All right. So we created a service for that load balancer. So let's get service. And now we actually have that load balancer for that. It has a public IP. And so if I'm right, it went to Azure and it said, I need a public IP address. And so it used the APIs that work between Azure and Kubernetes. access that and then apply it to the load balancer.
Yep. So there's actually something called the cloud controller. They renamed it. That's running inside the cluster that looks for very specific things like that, and it recognizes, hey, I just saw a service get created that's requesting a load balancer. It goes out and talks to Azure over the Azure API, provisions a load balancer, and wires all that stuff up. And if you really wanted to debug what was going on with that thing, you could give it the -D and tell it React clock basic so that you can see the logs from the individual container. But
let's see. So let's do pod.
And then give it -C React contain or React clock dash basic.
Got it. I don't know.
Error from server bad request. Previous terminated container React clock and pod.
Weird. Well, it looks like everything's up. And I just want to make sure we understood that once we created the load balancer with our manifest, it eventually went to Azure, and now we can see it's online. And we can look within actually Azure's native tooling. We can go to the Kubernetes cluster, and I will go over here, and let's just be jerks about it. And let's do, what's that command that we'll just repeat something over and over again?
Well, I mean, if you use watch, it'll run that shell command -N.
Well, I want to do a curl. I want to do a recursive. I want to just do a curl constantly, just so I can show them some traffic.
Yeah, so you could do that. You could use that with watch, and it would just show you the difference between the curl commands. But so you could just do a watch -N1, which would be every 1 second. And then
I should be able to do curl and then the URL, the IP address. So let me just do that.
I mean, there's a ton of ways
to bash
do
this. This is just the way I wanted it. This is exactly what I want to do. So now all we're doing is just throwing some traffic to this little cluster that we've got. And what we can do is go to the metrics, and we can pull up metrics and take a look at the different container insights metrics. We can see the CPU exceeded percentage. We can find out all this different information. We can create alerts around it. We can do all this stuff to find out how our application is performing. But you know what, Eric? We've come to pretty much the end of what we're going to be doing today. And I think we've learned a bunch of stuff. And you've helped me learn some stuff, and I really, really appreciate it.
Yeah, anytime.
So I have to do what I normally do when I'm here. I gotta pull up the closing music, and then get us ready to kind of say goodbye. So, Eric, would you tell everybody how they can find you, where they can get more information about what you're up to, all that stuff?
Yeah, I mean, you can hit me up on Twitter, which is my whole name, removing all spaces and punctuation, Erik St. Martin. You can email me, eric@eric.dev with a K. On Twitch, I'm eric.dot.dev. That's one place I'm different, but.
So let's play the little theme goodbye music. Hey, it's been great, Eric. Thank you so much for helping me out today. And
yeah, thanks for having me.
No problem. We'll see you next time, Eric. Thank you so much. Have a great day. Have a great weekend. And please keep doing what you're doing. It's so awesome.
Thanks. Bye.
Ooh, I got you too quick. Bye. All right, everybody. That's another one of these, another Azure FunBytes. I think we had a really great time together. I think we all learned some stuff. If you have any questions, you have any information you want to share with me, know that you always can. There's definitely ways you can get in touch with us. Use the Twitter, use the Twitch comments, leave something in YouTube, you name it. I just want to hear from you and know that you are enjoying what I'm doing. And if there's anything else I can do to make this more interesting, then I will. Once again, my name's Jay. Eric has been my guest today. I really appreciate everybody watching. I'll see you next time, next week. Again, 2 to 3 here on the East Coast. See you then.